complex numbers. So most people call complex numbers imaginary numbers, but technically, complex numbers are imaginary and real numbers combined. So usually, like I'm not going to put that Venn diagram back up. We had a Venn diagram, the very first section that we taught, on the different kinds of numbers, like integers, whole, rational, irrational, all those. All of those types of numbers are the real numbers. And then the other half of numbers are called imaginary numbers. And all of them together are called complex. Now the weird part is there's only one way to get an imaginary number. That's an I. It's a script I. J is the other hook, I think, isn't it?
Oh, you're right. I was like,
That's the best I can do for writing cursive script I. In a textbook, you'll see it's purposely written as an italicized script I so that you won't mistake it for some sort of a variable. But the only way you can get imaginary numbers is square roots and negatives. And so you guys kind of know that that's impossible because you can't multiply something by itself to make a negative. Probably the next question that comes to mind is why we would be learning imaginary numbers. And honestly, they are pretty specific. Like, very few are ever going to run into them in your normal lifetime. Where they do get used a lot is electricity. And if you become an electrical engineer, it's actually a big part of how they calculate a lot of different. I don't even know how to explain it. I don't know electricity good enough to try to explain this, but I know I was taught the beginnings of it to show how imaginary numbers were used. Like when they make those electrical diagrams, and you have like resistors and what are the other things on those called? Resistors. Nobody here in the robotics team? Help me out. Shoot.
Like just an electrical.
Like when you look at a motherboard in a computer, or
Oh, like circuits.
yeah, well, it's like a circuit diagram is where they make them, but there's resistors, there's all the little things.
Capacitors?
Sure, maybe. All the little things that are soldered onto like a motherboard, right? So the way that they can create those so they work is you actually use imaginary numbers for things to work out with electricity. It's kind of strange, but so that's why you're taught the basics and the beginnings of it now. So if it interests you, then that's something you can go into. Okay, I'll move on. I see that you guys are enthralled. All right. Every complex number is written with two portions, the real portion and the imaginary portion. Anyone in here who has a graphing calculator, it actually has a complex mode. So normally when you hit the square root of a negative, it'll pop up and say error, unreal answer or something like that. I can't remember the exact words. But if you hit the mode button, I can't remember if it says A plus BI or if it says complex. What does it say? A plus BI. Okay. So if you go to A plus BI mode and hit enter, and you do the square root of a negative number, it will give you the answer as a complex number with a real portion and an imaginary portion. So your graphing calculators have that capability built into them. I don't think most of the scientific ones do, but I could be wrong. I've never looked. So it's very possible your calculator can help you do this. You don't have to write this down if you don't want. I just wanted to kind of show you things. So this is where I was trying to explain that real numbers, they're a thing. That's what we did at the beginning of the year. Then there's imaginary numbers, which these all come from the same source. These are just different ones, like different.
So anything with the letter I is imaginary.
Correct.
And a negative in a square root 2.
So a negative square root of a negative, that's probably a better way to say it. Square root of a negative will create an imaginary number.
Cool.
And that's where the I comes from. So normally it won't be written as square root of negative 7. You would see it written as I times the square root of 7. Thank you. We're learning imaginary numbers. And the combination of these two together are the way they're written up above. So they're referred to as complex. So that's kind of just what I described out loud. Now, finding answers is actually really easy. It seems like because this is a whole new topic, like this should be hard, and it usually isn't. It's just kind of strange. So square root of 4 is 2. So if you have square root of negative 4, we basically treat the negative symbol separate than the 4. The negative creates imaginary version of 4. So it's 2i. And same with square roots that don't work out perfect. They work exactly the same as before, but if they were negative on the inside of the root, then that means it's an imaginary number, so I. Tracy, are you looking up all the imaginary stuff in Google? Actually, it doesn't give you a whole lot. If you Google it, it really doesn't even tell you much. I know. Now on the right-hand side in black, that's going to be what we end up doing. It's kind of weird. So square root of negative 5 is an imaginary number, but if you square an imaginary number, it turns into a real number. And that's actually how it's used in electricity. Yeah,
Is there a reason why the numbers are negative?
just because they can be. So if they are negative, this is what happens. Basically, you have never been given problems that had a negative answer like this, because before we would just say no, doesn't exist, something like that. Yeah.
Can you explain square root of negative 20, how you get to 2i square root of 5? I just don't understand that.
Square root of 4 times 10, and times 5, and the square root of 4 simplifies to 2, and then you times the square root of 5 by 2. And then you have the imaginary number that's negative.
I'm so lost.
He's not wrong. That's.
Hold on.
But I didn't have you guys do this before because I was kind of holding off till now. If you have a square root that can be simplified, so you would have seen the simplified answers in books and things like that. What you do is you look to see if there are any perfect square numbers in it. So 40 has a 4 going into it. And you can break it up into square root of 4 times square root of 10. And that's how you simplify square roots. It's not that it was hard, but I just didn't want to add on more things to you guys when we were learning factoring and all that. So then square root of 40 can be written as 2 root 10. This one was negative, oh, you said 20, but I did 40. Whatever.
Oh.
So if there was a negative on the inside, then the only thing that changes is you have an I as well. So the 20 has a 4 going into it, so you'd break it up into square root of 4 times square root of 5.
Okay.
Is that
Why
kind
aren't we doing like 20 if like 2 goes into it?
because 2 is not a perfect square root.
Wait, why is that?
Cause,
Here, no, that's fine. I'll let me make a new page.
1
I'm
times 1
lost.
does not equal 2, it equals 1.
So you are correct. You can break up 20 into 2 and 10. The reason we don't is because neither one of these works. Like, you can break it up into 2 and 10, but square root of 2 is nothing good, square root of 10 is nothing good. So what we do is, if you can simplify a square root, you would break it up into perfect square numbers, if possible. 4 is the biggest perfect square that goes into here. So you
Multiply that by
purposely
1.
choose, you purposely choose perfect square numbers.
So you pick the first number, as a perfect square, and the second number is what multiplies with that to get the big number.
Yep. I mean, like, you can have more than one perfect square even as well.
Right.
Like if you can't think of the biggest number, you can have more than one. And then basically anything that's not a perfect square stays in the square root symbol.
Okay, so then 2 square root 5 would then, okay, that makes sense actually.
Yeah.
And then this one was a negative to start with, so the negative symbol, where's green? I think that's green. The negative symbol turns into an I. Yep. Is that what I have down below? Yep, we just said that a bunch of times. Okay, now we're gonna start working with them slightly, like actual problems. So if you have complex numbers equal to each other, their portions have to be exactly the same. Like I have them highlighted in color coded up there. If 2 complex numbers are equal, the only way they're equal is if both portions are identical. So on this one, I have it split up as the real portions are equal and the imaginary portions are equal. It seems kind of weird that the problem has an X and a Y in it. And that's I mean, like, it doesn't stick out to you as super obvious when you first look at it, because the I is also there, so it basically just, it's like has a tons of letters up there. But I also know that the first numbers have to be equal, the second numbers have to be equal. So from that, I would be able to figure out what the X and Y stand for.
You divide it by the number, you divide each one by the number that has the.
Well, I basically just write 2 separate equations. So I take the first things equal to each other, and then I take the second things equal to each other. If there's an equation to solve, I do. You'll notice that I dropped the I part off. Yeah, I mean, I could have left it on, but it would just divided it away anyway.
Because you already split it.
Yeah. By the time we get to the homework on this, it's pretty easy. And I'm not saying that this can't get harder, because it does, but like the first parts of this that we learned, not bad. Somebody want me to explain anything that's up there?
So, for example, if for the 3x equals like 6, if the 6 had the x, would you divide them by 6 instead of 3?
Yep. Yeah, I only divided by 3 because it was 3x.
Had the x, and you
Yep.
divided by negative 10 because it had the y.
Yeah.
Okay.
If only like one of them, like -5 and like the thing, whatever it's called, like if only one of them has that, how do you divide it out? 'Cause I don't really
When you say that, like if we were only trying to find a single x or something, like
Yeah, or like that, the backwards J, whatever.
I?
Yeah, I. Like how, like if it was only on one of them, like -10 and not -5, like how would you like divide it out?
Oh, I see what you're saying. So, like if one of the halves didn't have an I, if it didn't have an I, then it's all just a real number. I'll write out what I think you're saying. Something like this.
Yeah.
You're not going to be given that because both of these are not imaginary. So both of these are considered the first part. You're not, no, I mean, it's a very good question, but you actually won't ever see it because there's no way they're equal if one of them has imaginary but the other doesn't.
Okay.
Because the only way they're equal is if both parts are equal.
Okay.
Yeah, no, that's a good question. But yeah, it won't, definitely won't run into it. Why do I have it all written out?
Because you're nice.
Seems very thoughtful of you.
Yeah, but I wanted to work it out with you.
Well, now you don't have to. Save some work for yourself.
Did I open the wrong notes? No, it says these are the ones that are supposed to be empty. All right. Well, it's Friday. I guess you guys could, you're probably okay wanting to break a little bit, but. The solving is going to be just like the test that we just took. One thing that you won't have to do with these is you won't be doing any type of factoring. So
Well, thank God.
factoring doesn't work with imaginary numbers in any which way. So you won't be doing it. Completing the square technically works. And and it seemed like some of you understood completing the square pretty good. Some of you didn't, and that's actually pretty normal. We're going to be learning another method, how to solve quadratic equations, so that you don't need to use completing the square every time. And actually a lot of people like it because it's just a formula where you fill in numbers. Hey, you got all these down already? Distance learning was the worst thing for students in terms of learning when not to use phones. Because everybody used them while you're on camera.
Did he actually? Well, when I was off camera, I did, but not when I was on camera.
You still can't tell if you're on camera. It's not like your phone's on camera.
Okay, but can you blame us? Some of these classes are really
Yeah,
boring.
Spanish classes are really boring. Trust me. English, you get it done in 30 minutes.
I was just saying it was bad for habits.
Everybody.
I wasn't like saying whether it was valid or not. Just, it's a bad habit to break out of. It's hard to break out of it. Okay, now that you probably got it written down, I kind of waited a little bit to explain it. So this one, because it was already x squared equals a number, I just take the square root to both sides to find the answer. Now where'd my mouse go? It works the same as when we did it before. When you take the square root of a squared, it creates a plus and minus on the other side. Square root of -81, it's not possible. So what you do in your mind is you do the square root of 81 regular, which is 9, and then you put an I because it was a negative.
So I means negative, right?
I means imaginary because the square root of a negative isn't possible.
Okay, yeah, so I thought it was like negative, because I was questioning why would we have like a plus and minus if we know it's a negative?
Oh, got you. Good question. I can be negative.
Or does it
So-
have to be?
No, it could be either positive or negative. The I just represents the square root of a negative number.
It's not possible.
Yeah,
Oh,
yep. Most people have an easier time trying to think of I as a variable rather than to try to comprehend yeah.
So, when you're doing like negative 81, like the square root of negative 81, we just kind of like do the problem as if it didn't have a negative and then put that in for your answer.
Perfect.
Yeah.
Yep. That is most definitely how I do it in my head too.
Awesome.
I pretend the negative's there. The hard part is remembering to write I at the end though. So it's kind of just training yourself to do that. Like it's going to be really easy for you to accidentally just write 9. The pro-
That would be wrong.
Yeah, well, it's a little bit wrong. I'll know what you're doing, but then the answer would be wrong, right? So 3x squared plus 75 equals 0. You know, it's not much different than what's on this side. Your goal is to solve for x on its own. So you subtract 75, divide by 3, and that would get you to x squared. And then you take the square root to cancel off the squared symbol. That automatically creates plus or minus. And then we had it down to square root of negative 25. So your answer is 5, imaginary. It most definitely will feel really weird using an I for imaginary. It really screws you up if you try to like think about what it represents. And that's why most students kind of treat it like a letter.
The biggest mistake with adding letters to math.
Kind of. I mean, it's pretty much what allowed us to figure out things. I mean, it created cell phones.
It should have been a symbol, not just a letter of
Well,
alphabet.
That is a symbol.
That is, yeah, it's the same
It's a
thing.
symbol.
You mean like you would prefer it to be like a triangle or something?
Yeah,
Got it. You can write a triangle.
That one's
Yeah, I mean, like, if you don't want to write an X, you can absolutely write a star,
it reminds me of things.
a smiley face, you know, whatever. Yeah, you absolutely can write just whatever symbol you want. I'll put this one up, but I don't know.
yeah.
I'll put this one up, and I can almost guarantee everybody's not going to do this once you learn the new way.
New ways for style 3?
New way is in a different section,
So tomorrow.
the quadratic formula. You have learned it in the past, but it sounded like everybody forgot it. Most students prefer the quadratic formula because it works for all of the problems, even if the quadratic formula is slower to do.
You mean the quadratic equation?
Mhm. Well, a quadratic equation, like this is a quadratic equation. Quadratic just means it has a squared. The quadratic formula is a way to solve every quadratic equation. So then you don't have to factor, you don't have to complete the square. So most students prefer it because of that. It's not quick. I mean, like, it's not quicker to use in any which way, but most students prefer it because it works for all of them. And then you don't have to learn how to do 3-term hard factoring. You don't, I mean, like, it replaces all of them. Factoring and things like that are much faster, but it doesn't mean people like them. Okay, so this is just a regular completing the square way of solving. You couldn't factor because there's no numbers that multiply to 5 and add to -2. So then the 5 was brought to the other side like we kind of were taught to do. Shoot. Why didn't you start it?
I thought you wanted me to do this.
No, that's fine.
I can do it later.
Yeah, no, that's fine. This is important too. I forgot what I was. As soon as I said move the 5 over, it reminded me that we were doing it before class. So completing the square, you take half of -2, you get -1. So I immediately wrote -1 in the parentheses below it. And then you square it to figure out what to actually add. So that's what's on the blank line. And then the ones are always kind of weird because it's the same number. Then you get x minus 1 squared, and then you'll notice it's equal to a negative number, which we wouldn't have been able to do before because it's not possible. I mean, it's not real. So now we can solve them with an answer, even though it's like not a real answer. It's an imaginary answer. So we still solve it the same way though. You take the square root of the squared to cancel it out. That automatically gives you plus or minus on the other side. And this one had a nice example because it was square root of 4, so that's 2. And then the negative on the inside made it I. And then when you add 1, you can't add imaginary and regular numbers, so you just keep them separate. And that's what a complex number is. So we're still solving quadratics. You're just supposed to be more used to it now, and now you're able to do any of them.
So if you get like an f of x formula, do you have to do that, or can you do other other styles with it, or is this the only style you can use on this kind of problem?
Do you mean like can you use factoring?
Like, can you mix and match?
You can mix and match. None of the complex number answers can be factored
Right.
because they'll all have combinations that don't work. So you can use both, you're just not gonna see it. You're not gonna get
Well,
one.
like if I do this problem with style numero uno,
Oh, no,
no,
I see what you're asking me, sorry.
got it. Now
This
I
has an
know.
X in the middle term.
Right, so you can't do that.
The first method only works when there's just a single variable like x squared.
So,
Yeah, because we took the square root right away. This one, you're right. If the letter is in one spot, you can do style 1. If the letter's in more than one spot, you kind of have to do completing the square.
okay.
No, that's a good question. Now, I didn't think you guys needed a huge amount of help on completing the square, but I don't know. I guess I'll emphasize, if you guys were having problems on the test, that should be kind of a big clue to you individually that you're gonna have to learn to ask questions. Like, cause a lot of you just like to sit there and just wait for somebody else to ask, or, you know, there's probably lots of reasons you're not asking for help. And while I understand it in one hand, you know, if you're having trouble and you wanna do better, that's kind of pretty much the primary way. I can't remember how far we go today. I know I looked at it right before school, but I don't remember.
Can we stop here?
Why?
Just for, kicks and giggles?
Oh, no, this is the last thing.
Perfect.
We have homework?
Yeah,
Why?
you always do.
We just had a test.
You didn't have any homework yesterday. And we took 2 days to do the homework that you did have from Monday.
Shoot.
You guys are okay. Now, the conjugate pair is going to be useless to you for currently. Ugh.
Like the answer for the last problem being the find the zeros one? No. Okay.
No, the finding the zeros is kind of a normal style problem. What I'm trying to say about the conjugate pair portion here is you're learning this for a method that we're going to do on Monday. So rather than having you learn that method all at once with a lot of parts. But like the last problem we did, the answer was 1 plus or minus 2i. Those are referred to as conjugate pairs of each other. And again, it's okay if you don't get why we're learning conjugate pairs yet. The key part to take out of this, should we go with Naruto?
Yeah, we should.
See, look at that. Look how quickly I learned.
We're so proud of you.
Yeah. What's the only difference in the two things that I've highlighted?
There's a positive
Perfect. The only difference in conjugate pairs is the imaginary number is alternated between plus and minus. The first number is identical in both of them. The second number, the imaginary portion, is plus or minus. Like they're opposite. Weird. Keep your guys' phones away. I'm okay with you using them when we have time for it. And we will have time today because we're just about done and it's quarter after. You'll have time to work in class. Why don't you guys see if you can write the conjugate pair to all 5 of these? If you're able to do all 5 of these, then that's all the more complicated the conjugate pairs get.
That's how complicated it is.
Just conjugate pairs, not the problems. Once you get conjugate pair ideas, then they click. I can't believe you're the only one dressed up now that I take notice.
Yeah, it's a little depressing actually.
I was expecting most people to dress up. Is it throwing you off because it's on Sunday instead of?
No, I actually forgot Halloween was a thing for a second.
All right, it's fair enough.
Legit forgot Halloween was this week.
Is that your watch?
Why don't you
It
guys
was so
get
faint.
to dress up?
What?
Why don't you guys get to dress up?
It's a good question actually.
I didn't really ask for details.
That seems like one place you would dress up for. So,
Yeah, it seems like a pretty.
I mean, like, it's very possible. I don't really know.
I think it's religious.
I've never really paid that much attention, like, into the details behind Halloween. You know, every type of holiday has some sort of a meaning behind it, and honestly, I really have no idea. It's not that big a deal. I just like the candy.
That's a good answer.
I mean, look at me. I like the candy, all right? I like that it's on sale at stores. This is when my favorite day is November 1st because all of the Halloween candy is 50% off.
That is true.
You go to Walgreens after holidays and candy is really cheap. That's when I buy it. Because I'm cheap and I like candy.
Valid points.
Okay, I'm assuming you have stuff written down by now. Jaden, I feel like you can pick the next person. Oh, unless you wanted to go. No. Okay. My roller's kind of broken, so.
Alex, you broke it.
Can you?
Yeah.
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 A. What's the conjugate pair of 9 minus I? First number stays the same. Good. Second number goes opposite. Perfect. That's the conjugate pair. First number stays the same, second number opposite. Once you get that pattern down, there's not much to it at all. Alex, next person.
Nico.
Okay?
-4 minus 3i.
Perfect. Perfect. C is probably the trickiest one out of all of this. Maybe not, but who knows. Next person? Nice, very nice. So this is kind of like saying 0 plus 6i. And on the conjugate pairs, you just change the imaginary number only. So this one doesn't have a real number part, so it's -6i. Very good. That was pretty good. You have somebody you want to call on?
Would it be 2i plus 15?
No, but I understand why you're saying that.
Oh,
So up above, which one did we change?
The second one.
True. The second one is normally imaginary numbers, but if you look at D, the imaginary numbers first.
So it'd be negative 2,
And then how about the second number?
plus 15?
Close.
Negative 15?
Minus 15. I like how you listed every option though, because then one of them's right. So you're just changing the imaginary number each time. The real number stays the same. So if for some reason they're reversed, which they shouldn't be, but if for some reason they are, that's what you would do. Anybody want to do the last one? Oh, unless you want to call on somebody in particular.
No.
Okay, go ahead.
Negative I plus
Good,
square root.
good, good. This is as tricky as they get. Almost, I'd say 99% of the numbers you're going to run into look like A and B, where you'll have both numbers and written in the correct order. Yeah, go ahead.
So is the homework like this?
Yep. It is. Okay, we are done. Nice job. Reminder, refresher. So we have school Monday like normal.
And then no
Tuesday's election day, so there's no school on Tuesday.
election for what?
Man, we could have Monday on too.
We could. You know, that'd make it a lot easier.
We never even used to get election day off. We partially have it off now because most of the schools are used for as voting sites.
Right on.
We get plenty of days off. I know.
We need more.
Need a little push.
Okay, so the reason I bring that up is if you are somebody who is behind on homework,
Oh.
you should probably start catching up. And you should have used the MEA days off, and I saw not a lot of people did. That was partially why I didn't assign anything over MEA. But Tuesday is most definitely when I have to start calling parents about lower grades and missing things. So I guess if you're somebody who doesn't want to come home, try to turn things in by Tuesday, because that's when I'll call.
So you're gonna call things missing?
Yeah. I give you guys the opportunity to be mini adults and to be responsible for yourself. And if you can't, well, then I call.
We don't want that to happen.
Some people don't. Some people do.
Wait, some people want you to call their parents?
Well,
I think my parents
I shouldn't
want
say
it.
some people want them.
Just wanna call it big guy.
Some people need motivation to get things done.
That's true.
That's not good.
And whether that's from me or from parents. Basically, if you're a procrastinator, you need motivation.